Hi everyone! In this tutorial we will learn how to take a set of blend shapes and convert them into a different topology. Why would you need that? As you may know, wrap allows users to work with a custom topology. However, for some nodes like blend wrapping, facial wrapping, or point detector, you need to give it not only a neutral base mesh, but also a set of blend shapes with the same topology. Wrap uses this set of blend shapes to analyze how a face can be deformed. But in practice, the neutral base mesh is often the only mesh you have, so you need to somehow create all the blend shapes for it. What you can do is simply take an existing set of blend shapes and convert them into your topology. So let's see how we can do that. I want to start with loading a mesh with a custom topology. Let me drag and drop the OBJ file here. In this example, I'm going to use a very nice mesh purchased from 3D Scan Store. The mesh is stored in a meter scale. Let's change the scale parameter to 100 and convert it to centimeters. I'm going to click F2 and rename this node to Target Topology. Let me also change the color of this mesh to orange. Alright, now we need to load our blend shapes. For this example, I'm going to use the blend shapes that come with Wrap's gallery. We can pick any of these expressions. I hold Ctrl and click on the light bulb button to make this node the only one visible. Let's rename this node to Reference Blend Shapes. Now let's click on the Browse button and instead of one model, select all the meshes at once. As I switch frames in the timeline, Wrap loads the next model from the list. Next, I'm going to wrap our target topology to one of the reference blend shapes in the list. As an example of such a blend shape, I highly recommend choosing an open mouth expression. This will prevent lip artifacts when transferring the topology. As you can see, the models are not initially aligned. We can easily fix this by roughly adjusting the model position by using the transform gizmo. Now let's create a wrapping node. As a first input, it takes my target topology. The second input will be the blend shape. In order to make the wrapping process more accurate, let's specify the point correspondences between the models. We will do this by creating a select point pairs node. Let's connect the inputs in the same order as we connected them to the wrapping node. Next, I'll go to the Visual Editor tab. Let's turn on the Sync Views mode to control both views at once. Let's start with the center points on the lips. Since we are working with symmetric models, we just need to specify points on one side and symmetric points will be added automatically. To do this, for the left and right views, let's switch the symmetry parameter to topological mode. We can now proceed to set the points for the eyes. As you can see, the points for the second eye have been added automatically. Let's also add points at the corner of the lips. Alright, I want to add one more point on the ears. Okay, now that all the points are selected, let's use them as the third input of the wrapping node. As the fourth input, we need to specify 3 polygons. 3 polygons are those that should not be fit to the surface. In this case, the target topology contains eye sockets, but they are not present on the blend shapes. Let's create a Select Polygons node. As an input, I take the target topology and go to the Visual Editor tab. I'm using polygroups to select the polygons of the eye sockets. All that is left is to connect 3 polygons to the fourth input of the wrapping node. Let's go to the Visual Editor and click on the Compute button. The wrapping did a pretty good job, but I would like to adjust the mesh on the lips and eyelids. For this we can use the Brush node. The first input of the node will be our wrap topology. The second input will be the reference blend shape, and the third input will be our original target topology. Now let's go to the Visual Editor. I set the symmetry mode to topological. Let me also turn on the Use Geodesic Distance option. I'm going to use the Relax Project brush to get rid of the artifacts in the center of the lip. Now let's smooth out the mesh at the corners of the lips. Good. The rest is to fix some artifacts on the eyes. I'm going to use the clone brush for that. Super. To apply the changes, let's press the Accept button. This is how our model looked before, and this is how it looks after. Before and after. Now let's save the model to disk. To do this, I right-click on the last node and choose Save Geometry from the context menu. I'm going to call this file Target Topology Mouth Open.obj. Great, now we can move on to the second part of the tutorial. For simplicity, let's create a new project. But first, let's copy the reference Blendshapes node. We will need this node later. I go to the menu and select File, then New Project. Let's press Ctrl-V to paste the copied node. I'm going to change the duration of the sequence to 36 frames, which is the same as the number of Blendshapes we are using. Let's drag the wrap target topology into the project. I'm going to call this node Target Topology Mouth Open. Also, I want to change the color to orange. In the previous step, we merged the target topology and reference topology in frame 29. In that frame, our mesh has an open mouth expression. We can now automatically fit the target topology for any other expression. For this, I'm going to use the lattice node. As the first input, I take the target topology with the open mouth expression, which we are going to deform. As the second input, we should take the same expression, but in the reference topology. We can't use the reference Blendshapes node here, since its geometry changes as we switch frames on the timeline. Instead, we can make a copy of the reference Blendshapes node. I'm going to call that second node Mouth Open Reference. Let's press the Browse button, and instead of selecting all the files, let's pick only the Mouth Open expression. Now let's take the output of the Mouth Open reference node as the second input of the lattice node. It's important that the first and second inputs of the lattice node should have a similar shape. In this case, it's an open mouth expression. As the third input, we take the sequence of the reference Blendshapes. Perfect. Now if we switch frames in the timeline, our mesh will change its shape. As you can see, there are some artifacts on the mesh. Let's increase the neighbors parameter to 30. Now the result looks much better. However, for some frames you may see defects inside the eye socket. This occurs because the eye socket is present on the target topology but not on the original Blendshapes. To fix this, we can replace the back part of the socket with the original shape. Let's do this using the Mix Geom node. As the first input, we take the result of the lattice node. As the second input, we take the original topology. Our third input will be a vertex mask that will determine which parts of the model need to be replaced. So let's create a vertex mask node. As an input, let's take the original topology. Now I'm going to the Visual Editor tab. Let's set the mask color to white. Also, I changed the symmetry parameter to topological. Next, with the help of a brush, let's paint a vertex mask for the eye socket. Good. Let's take the vertex mask as the third input of the Mixed Geom node. Here's the result before the fix, and here's after. Before and after. Now each reference blend shape is represented in our topology. This method is not ideal. For expressions like this, you may notice that the left eye isn't completely closed as in the original blend shape. Manual cleanup may fix the problem. However, for some nodes, such as blend wrapping, facial wrapping, or point detector, this result can be sufficient. Okay, all that's left to do is to save all the blend shapes to disk. To do this, let's create a Save Geom node. As an input, let's take the result of the Mix Geom node. Now let's save the project. I'm going to call the file Converting Blend Shape Topology. Okay, I want all the saved expressions to have the same names as the original blend shapes. To do this, we can write a small Python script for the file name parameter. First, we use the node param_value function to read the name of the original blend shape. As the first argument, you need to specify the name of the node, reference blend shapes. As the second argument, you need to specify the name of the parameter, file name. By pressing F5, the expression will return the name of the current blend shape. Let's save this name to the variable file name. Now let's import the OS module. The resulting path will consist of the path to the project file, project directory, then there is a subfolder, Converted Blend Shapes, then there is the base name of the original blend shape. If we press F5 again, we can verify that the result is correct. Let's press Accept to apply the expression. If we switch the frame on the timeline, the value of the expression changes accordingly. All that is left is to click on the Compute Frame Range button. Let's set the number of parallel processors to 15. And now we can press Start. In just a few seconds, all blend shapes were converted to the new topology and saved to disk. As you can see, the file names are identical to the original blend shape names. Now you can use these blend shapes for further steps in the pipeline. Okay, that's it for this tutorial. Thanks for watching, and see you in the next video.